one thing I want to focus on today is gasless flux core, or what is more known as self-shielded flux core. The reason why we call it self-shielded flux core is because the wire provides the shielding. Now, this self-shield was primarily designed sometime in the 1950s in order to take place of stick welding. Now, that never happened because stick welding is just way too convenient. But gasless flux core can be just as strong as any other weld. You just got to know how to set it up. And that's kind of what I'm going to focus on today. So this is kind of an example of what I would do with you guys as a live sessions. It's not going to be as long, it's not going to be quite as detailed. You kind of have to join. January 10th is the first date, but you get the idea. So when I say that it can be just as strong, what I mean is a TIG weld can be just as strong as a stick weld, can be just as strong as a flux core weld, can be just as strong as a MIG weld, and so on. It's all about the filler metal and the techniques you use. With that being said, I'm going to compare the two. I've got two coupons right here somewhere. Okay, they're 11 gauge. They're 1/8 inch. 11 gauge is about 1/8 inch thick, a little less. And I'm going to do a T-joint. I'm going to cut them in half, and for one, I'm going to do a TIG weld, and for one, I'm going to do a flux core weld. Same size. The only difference is that the filler metal is going to be different. Flux core E71T-11 flux core wire. It's the same stuff you can pick up at Tractor Supply. Now, luckily for the live sessions, I have Blue Demon Welding Products supporting and sponsoring the program. So we'll be using pretty much all their filler metals. And you can get all their filler metals on their Amazon store. So, but for right now, I got the Tractor Supply stuff, not even Harbor Freight, the Tractor Supply stuff. I'm gonna cut these two in half here. That way we can do one a TIG weld and one a flux core weld, and I'll explain. Get this out of the way. Try and make as little noise as possible. People are sleeping. Okay, these are all mild steel. Cassie, thank you for the subscription. If you want to learn how to weld live sessions, become a member for $10 a month. I'll be able to teach you to weld live. I'm also going to work on doing live chats. I'm also going to work on doing live sessions where we all kind of do this community group live thing where you're on live as well as me, and I can do some kind of instruction with you, if that's something you want to do. So, in order to do that, I grab some of my filler metal here. For the TIG weld, this is what I'm going to use. Okay, this is ER70S6. Okay, it's just standard TIG wire, nothing fancy. That's for the TIG weld. For the flux core weld, I've got 030 70S6, or not 70S6, 030 71T-11 filler wire. The thing is about the filler wire is what makes the strength of it is its tensile strength. That 71, or that 7, in the electrode classification, and the 70S6, the 70 in that electrode classification dictates the tensile strength of the filler metal. So, if the weld is done properly, both welds have 70,000 pounds of tensile strength, so ideally they should be the same. Which would be stronger than this material. This material is just standard mild steel. It's going to be same quality, like A36, 36,000 pounds. Cassie, if you go onto the YouTube members page, if you go on the Stickman Fab YouTube channel, the main channel, find the membership tab and select join. It should be live sessions tier, $10 a month, every month. And it'll be 2 live sessions on Friday evenings. And you can also go, if If you miss them, you can also always go back to them. I'll leave them up for members only. So, first things first, I'm going to do the TIG weld. The TIG weld is going to be, as far as the laser welding is concerned, to answer that question, I don't know. I don't know enough about them. I would love to try one. I think it's a cool concept, but Cassie, let me know if you can find it. Anyways, so first thing I'm gonna do, I'll put this in my vise, and I'll do my TIG weld first. So give me a second to set this up. Wherever my plug went. Put this in. Right. Now, I'm also going to use, this is the one thing about TIG weld. Now, of course, everybody has told me before, or I've heard from a lot of people, TIG welds are the strongest welds. The reason why people say that is because TIG welding takes a lot of concentration and focus on detail. You can see pretty much everything that's going on. That's not what I'm looking for. That's what I'm looking for. So, of course, you are going to see everything. So the weld is going to be easier to check for discontinuities and defects. However, that does not mean that the weld is stronger because of the process. One process, where's it at? There it is. One process is not necessarily stronger than the other because of the process. It would be stronger because of the filler material used most of the time. So I'm going to take out my stainless stuff here. This is all, lens in here for the 16. We're going to put in some 332, 2% thoriated. Most common tungsten used on mild steel. Any welding school is going to carry this majority of the time. Okay. And of course, standard 70S6 filler metal. Okay. Oh shit. Why did I grab it on? Hold, please. I'm just having some technical difficulties here. There we go. And there's an owl. Very close to me. There we go. That's properly adjusted. So, for my TIG, DC negative, like you normally would, I'm going to give it the best shot at working. And we're going to go with my pulse settings, 4T, DC. I'm going to use my standard pulse settings that I always use. And we'll do a TIG weld. Now, of course, for the TIG weld, you also need to have shielding. So I'm going to use 100% argon like you typically would. I'm going to put it right here. This camera is going to stop following me around. I also live on Facebook too. Shit. There we go. Move this camera down a little bit. This way. There we go. All right. This TIG gloves. I'm not sure where they are right now. All right, well. That. Make sure the grounds are hooked up, and they are. 70S6. Let's get tacking. It should be pretty clean. I got this stuff. RTS, I'm showing the difference between a TIG weld and a flux core weld to show you that they are the same strength, as long as they're done properly. So I'm just going to do a standard corner joint right here like that. Okay. I have pulse settings set up and everything. I'm going to give this the best chance of being stronger. All right, so tacks are in. We're gonna run it at 100 amps, okay? 100 amps, and we're just gonna go across 332nd, 2% thoriated, 332nd, 70S6 filler, and we're just gonna make a solid TIG weld here. Come on now. Okay, now, that's basically it. Plain and simple. That's our TIG weld. Okay, came out pretty good, right? Nice and straight and even. Got good penetration, heat affected zones, pretty large, but we're all right. Pretty good. Now, to do that weld, that material needs to be extra clean. Excuse me. Material has to be clean. You have to have the right filler metal. You also have to have the gas. You also need the machine. You also need the tungsten. You need all that stuff. I can make the same strength. I'll call strength. Same strength and even same quality of weld with flux core. Remember, this is Harbor Freight. Or not Harbor Freight. This is Tractor Supply quality stuff. This is not, you know, this isn't Blue Demon wire. This is just Tractor Supply. But if you have the machine set up right, there's no reason why you can't make a good quality weld doing it this way. So switch over to my big machine. Maybe. Now, for flux core, it's obviously gasless flux core. So, it's not Hobart, it's Job Smart wire. Even better. I have 030 filler wire, and I have the welding machine behind me. That's it. I don't have any gas. The material doesn't need to be super duper clean. I don't need to have a tungsten or anything like that. It's a much simpler process. Okay? Not as detailed. I'm going to make sure this thing's dialed in the way I want it to be. So I'm just going to take a scratch piece here. Yeah, we're pretty good. All right. So again, same material. 11 gauge wire, you guys saw me cut it. 11 gauge material. Cleaned off pretty good. Do the same corner joint, okay? All right. So two main differences. One, it's gonna make a lot of spatter. Two, there's gonna be a lot of smoke. All right, those are the downsides. All right. Hopefully, I have enough wire to do this because I am running very short on this stuff. Here we go. Flux core wire, nice and simple. Same size, corner joint and everything. Let me get this camera to stop moving on me a little bit. Here we go. Okay? There we have it. And notice the weld takes a little bit less time. Now we also, again, there's a layer of slag that it creates. I can fix that with a wire wheel. Let's see what we got. Backside looks really well penetrated. Okay, there's the weld. Okay. Still came out pretty good, right? I think so. I think it came out all right. There you go. You get the settings up right. It still looks halfway decent. I don't need gas. I don't need to make settings for a while. Now let's compare the two. Come here. Let's compare the two. Okay. This is my flux core one. This is my TIG one. Now I'm fairly confident in my welding skills, both flux core and TIG. I've been doing this for quite a while and I figured it out. Looking at the TIG one, okay, you can see, let's try a little pointer. You can see right here, all this slag that built up, okay, on the back, or mill scale, actually. That means I've got some really decent penetration here, okay? You can see the heat affected zone on the clean wire. It goes clear out This side, it's a pretty large heat affected zone of carbon steel. Not too bad. Flux core. Looks more or less the same thing. Looks like I might even have a little bit more penetration on this bottom side than I do the top. Not that big a deal. Heat affected zone goes far out. It's a little bit more pronounced. Leads me to believe I had a little bit more heat input into this piece. But overall, also looks pretty good. Yes, TIG welding looks better. Of course it does. You also have more control over your heat and all that stuff. But TIG welding takes a lot of practice and a lot of skill. Flux core, it's quicker to learn. You can do it on projects. You can do it on dirtier metal, stuff like that. And to prove it to you, obviously I'm going to do this live, it is just as strong as the TIG weld. So when somebody tells you that TIG welding is stronger than MIG or stronger than stick or stronger than flux core or whatever they're trying to say, it has nothing to do with the process. It has everything to do with your technique and your skill. And the filler metal you use, obviously. Because if you use the wrong filler, well then you're screwed. So I'm going to attempt to break this off. Now, since I've only welded on one side and I did a quarter joint, chances are I'm probably going to break both of them. But we're going to see how hard it is to break them. If I don't break them, that's a good sign. That means these welds are stronger than what they're intended to be. Nope, I don't think it's gonna break. You see that catch? I don't think it's gonna break. I mean, it might. It's bending the material. Believe it or not, the only hammer I have handy right now is this thing. There we go, we broke it. That's the TIG weld, by the way. So yeah, when you do a fillet weld break test, that's how you do it. You go right across the backside like that. Like I said, I intend these to break because I didn't weld these on the backside. Alright? But we can also see if I made any mistakes along the way. So yes, that did, obviously it did snap. I did it on the weakest point, but you can see it bent the material pretty good, and it took a bit of force. I want to see the penetration power here. I can break it off. Let's go over to this one. So this one is the flux core sample. Again, I'm going to break it on the back side. So I intend for this to break, but we're going to see what type of penetration power we got and see how hard it is to break. Or it won't break, which proves my point yet again. I don't know if I'm going to do this one to break. My vise is broken. That's good. Alright, new plan. Put it in the vise like this. You guys can't see it on the Facebook side. Hey, get back here. Now, the nice thing about doing this live is that there's no editing tricks here. So you can be assured that I'm not lying to you. I'm not coming up with any crap. This is real. This is the flux core one. I'll prove it to you here in a second. I'm trying to get it to break. It's not gonna break. Oh, actually it is gonna break, just not where I thought it would. Oh! That's as much as I can get out of it. So that actually further proves my point, which is not what I initially intended. Flux core weld. Okay? You can tell because I've got slag in the corner right there. Flux core 1. Okay? Peekaboo. There we go. So flux core 1 didn't break. I even made the same size weld. Matter of fact, it's a little smaller. The TIG weld broke, which is, you know, like I said, I kind of intended for them to break. But, hey, just further prove my point. So, next time you see the question, somebody asks a question, what's a stronger weld, TIG, MIG, or stick, or whatever, tell them it has nothing to do with the process, everything to do with the filler metal. I'm trying to break this apart so you guys can see. Come on now. All right, well, with the simple tools that I have at hand at the moment, I didn't add quite enough reinforcement on my TIG weld, so it cracked. So you can make just as strong as welds with a flux core wire, even the ship from Tractor Supply, as you can from a place like, or as you can from a TIG weld. There we go, now it's broken. Okay, and it broke right down the center. Now, like I said, that weld is nowhere near strong enough. I should have added more amperage. I should have added more filler, but that even further proves my point. You can use a flux core machine with the right filler, with the right settings, on a 110 circuit. Look what it's plugged into. This is the only outlet I have in my garage. Well, I have other outlets, but this is the only size outlet I have. It's a 110, or 120, or whatever you want to call it. It takes less amperage, less heat, less total heat input for a flux core weld. The amount of amperage that I was putting through the workpiece would be roughly 75, 80-ish amps at one time. I had to set my TIG machine to 100 amps. Do that. See what I mean? So if you want to do a project such as, I don't know, this mower right here, I guess this flux core is not a bad option. I know you guys just had Christmas. I don't know if you guys got any welding machines or any equipment. God. You know, that's some of your gifts, but if you want to subscribe to my channel and then become a member, live sessions tier, $10 a month, every month. First night I'm going to do it is January 10th, 9 p.m. Eastern Standard Time. I'm going to start from the basics. Now, when I start meaning from the basics, I want to see what the people that are attending it, what process are we planning on using? Are we planning on using all of them? Which ones you guys want to touch on first? I'm going to be able to get a list because I'm also partnering, or well, Blue Demon Welding Products is sponsoring this. So I need to get with him and see what exactly they want me to, or what they can provide in order for us to get the proper equipment. That way I can get the proper filler metal, show you exactly what you need to do. So, anybody has any questions, I'm gonna be on here for a little bit, just kind of putting stuff together, nothing really as far as work's concerned. But I wanna open it up to questions, as if you guys couldn't ask questions before, but this is kind of a Q&A session here. And ask away, whatever questions you got. I'm just gonna start putting stuff away. I might jack up my tractor here and take a look at what I got to do, because I got steering to do yet. But yeah, there's your example. Kind of pisses me off about that TIG weld. I bet I can make a. Well, hell, I got the material. I've got everything set up. Let's do a better test. That flux core weld didn't break. Let's do another one. One more. For the boys. For anybody who wants one. This time we're going to turn do 120 amps this time. Get some real, get some of that juice flowing. This thing. Oh my God. 14 times 2. Yeah, that's fine. All right. New pulse. We're going to 120 amps. 3/32, 2% thoriated. With the same 70S6 filler metal. I need my hood. Oh. Alright, so this will be kind of the same thing. This time I'll put some more heat input into it. See if I can make a weld that doesn't break on a reverse fillet weld break test. A lot more heat input, a lot more concentration. A lot of heat, still a little convex. We'll see what it turns out to be. $120 amps. So now we're almost double what that flux core machine required to run for the same weld. Again, we're still a little concave. I don't really like it too much. We'll see. Let it cool down a little bit, give it the same opportunity. Yeah, it's concave and low. We'll see. Alright. Have the same thing. I'll just stick it in the vise and see if I can. Well, looks like I'm gonna have to get a new vise soon. That's better. There you go. Just took more heat input, but all it took. go. All right. I'm not stupid, I'm not crazy. Bless me. Excuse me. Do I have a 240 in the garage? No, I do not have a 240 volt in the garage. I do have a generator that is right outside my window here that I plug into that gives me 240 and whatever I need. The generator is not just a generator, it's an inverter generator, which gives me clean power to these machines because inverter welding machines need clean power. So it's an inverter generator with 240, and I use it a lot. But for the sake of the classes, I'm gonna stick with 110 because that's what, or 120 or whatever you wanna call it. That's what most people have in their garages. So, if you wanna go on my YouTube channel, select memberships tab, $10 a month every month, you get 2 live sessions every Friday, every other Friday night, 9 p.m. Eastern Standard Time. Or if there's, you know, we have a group of people and they say, hey, Wednesday night works best, I'll make it work the best way I can. I have a full-time job where I'm a weld instructor as well, so, and I do weld inspection on the side, so I'm a little bit busy, but I can make things work. But for $10 a month, live sessions, teach you how to weld live in your garage. I can give you feedback right away, and I want to work on this thing where I can get on almost like a Zoom call where we're all welding together remotely. I think it'd be pretty cool if I can set that up. I just need enough people to be interested. Yes, I'm a, question is, am I a CWI? I am a certified welding inspector, certified welding educator. I am also part of the committee that writes the code books. So I also have a hand in interpreting, understanding, and editing the code books that go into the industry. So, and I've been a pipe welder for 15 years. I still do welding on the side like this. I started off stick welding, even though when I first started stick welding, I hated it. But now, of course, it's my bread and butter. And I've had to learn all processes. The CWI test was the hardest test I have ever taken to date. Written. I'm glad I did the 1 week instructor-led training course. I also did the 8-week online seminar where I worked through the workbooks. And I'm glad I did because there's a lot of stuff that I didn't realize I didn't know. And I went in underestimating this thing, and I still think I overestimated it. I passed first time, which is apparently a hard thing to do, but I'm going to tell you right now, that test was tough. I'm glad I'm a nerd. So rather stick weld than run TIG. Be honest with you, I'd rather stick weld any day of the week. That is what my online welding program was supposed to focus on. But like I said, if I get a bunch of people that want to see something else, I will do something else. But I plan on starting with stick welding. Yes, the TIG welding can be very slow. It's not always slow. But yes, typically TIG welding is a much slower process. A really good TIG welder can make it really fast, but I'm gonna tell you right now, that's not quite me yet. I'll get there, just not yet. So I'm gonna set this up for my stainless stuff. I'll also get to show you guys. Do I have it handy? I might have it handy. No, I don't. So there's a lot of people that think because I've been a welder for this many years that I must have started on something cool. I must have had something like a Lincoln SAE 300 or an SA 200 red face that I started on or something like that. That's not the case. I started off welding my first experience welding outside of school was a Chicago Electric stick welder that was ran on a 240 volt line that my dad ran for me in the garage so I could do projects in the garage. And the machine did fine. It was nothing to shake a stick at. It wasn't anything, you know, crazy, but it worked. It would run 7018 no problem, run 6013 no problem, run 7011 like a dream. Wouldn't run 6010 save its life, but most inverters actually have a hard time doing that. But my first machine, honest to God, was like 90 bucks. So you don't need a lot of money to start. Matter of fact, I can do something else for you. Well, I have you here. Put this over here. Okay, I'll do something else. I'll do another demonstration. And this will be another thing that I want to teach in this welding lesson curriculum that I plan on doing where you're doing live lessons with me. So for those of you that have not caught on yet or started a little late, if you go onto my YouTube channel, Stickman Fab, for $10 a month, I'm going to do live lessons 2 Fridays a month, every month. Try to do every other Friday night, 9 p.m. Eastern Standard Time, and I'm going to teach you guys to weld in your garage. Don't need 240 volts. You don't need a fancy welding machine. Matter of fact, you really don't even need a welder to join, because I will teach you regardless of whether you're welding with me or not. Now, I plan on doing live chats, do this whole community thing where we're all sharing pictures and whatnot of projects that we're doing, kind of featuring you guys in some of my other videos. And I also want to do projects with you as well. For example, I'm doing this lawnmower go-kart project thing, and some of the stuff that I want to teach is also on this project. And I can do examples of like what you could do at home. So one of the examples that I want to do is that stick welding is my forte, something that I've done for a very long time. I like to think that I perfected it. Maybe that's true, maybe that's not, but there's a lot of, I have yet to come across anything that I haven't stick welded. For example, Fred, your question, ever welded cast iron? Now, you asked me if I weld cast iron with flux core. No, I have not welded cast iron with flux core, but I have welded cast iron with stick welding. And you get a nickel 55 or a nickel 99 electrode. Nickel 55 is 55% nickel, the rest of it is iron. Nickel 99 is 99% nickel. I use nickel 55 on a lot of cast iron stuff, including stoves, like wood burning stoves and stuff. Preheat it to 500 degrees, run the rod, and then you slow cool it. I've had an instance where I had to repair a cast iron wood burning stove, and we didn't find out until, you know, they started the fire that it had a crack. And they said, we'll put it out, and then when you come up, and then you can weld it. I said, no, leave the fire on. They said, what do you mean leave the fire on? I said, leave the fire on because there's my preheat. And not only that, that's my post heat. So we don't have to worry about cracking. So they left it on. The thing was roughly 400 some degrees. I preheated it a little bit to get it up, and then I just ran it. Fixed the crack, a couple little holes in it just to keep it from traveling, and then there. Fred, I want to try one of them Arc Captain plasma cutters. Honest to God, for the price, plasma cutters are a super cheap, super simple piece of equipment. I have a Yes Water plasma cutter that costs $249, and it works great. I can cut 3/4 inch plate with it if I really wanted to. I don't do a lot of it, but you can. So if you're looking at doing it, you're looking at trying it, you need a plasma cutter in your life, as long as you have about as long as you can run 4 cubic feet per minute out of your air compressor at 90 PSI, go. Oh man, I just answered this question. What's stronger, flux core or stick? You'll have to watch my video earlier in the video. Because I kind of answered that question. It has nothing to do with the process. It has everything to do with the filler metal. So as far as flux core or stick, it does not matter. It's about the filler metal. Tin Man, if you want to subscribe, Become a member for $10 a month. I'll teach you how to weld in your garage, and I can make your welds look mighty fine. I think you'll be all right. But one of the examples I want to show you is that stick welding is something that I really come to. And the one thing that people don't believe is that you can stick weld stainless steel and aluminum. Let's do that one too. You know what? You're here. Let's do it. Okay? Stainless steel and aluminum. You can stick weld this stuff. Believe it or not. I'll show you. Okay? We'll start off with the stainless. These are pieces of probably 12 gauge. I would guess probably 12 gauge. This came from weldmetalsonline.com. If you guys want to get weld coupons from weldmetalsonline.com, use my code StickmanFab24. You can get 10% off everything. So, Fred, yes, that's pretty accurate. You can stick weld just about anything. You can TIG, not including non-ferrous metals. For example, you can't stick weld copper or brass, silver, or anything of that nature. Tin Man, yes, I would definitely order the books first. Go through the WIT book, Welding Inspection Technology book. That book kind of gives you all the information you need for part 1. Part 2 is also the practical exam where you have to basically learn not only how to read a code book, but also how to write and understand welding procedures. So, anyways, I'm gonna get back to this. Stainless steel. What we got? That's not what I want. That's also not what I want. I got a lot of stuff in here. Ow. There we go. 308. No. Come back here. Okay, hey. Oh, no, you bitch. Okay. All right. So, stainless steel and aluminum. We'll start off with the stainless steel. Okay. And yes, these are stainless steel coupons. These are 300 series stainless. 300 series stainless is not magnetic. This is a giant magnet. Okay. As you can tell by it sticking with a bunch of this. This is 300 series stainless. Not magnetic. Okay, so it is stainless. These coupons, coupled with, now this is a Blue Demon rod, E308L, E308L, stick welding electrode. Yusaka asked, would stick welding aluminum be as strong as TIG if done properly? Yes. It is all about the filler metal and your technique. It has nothing to do with the process. So yes. And again, I'll show you. Don't you worry. 308. This is 332 from Blue Demon. Blue Demon is a sponsor. Matter of fact, as of right now, they are the sponsor of the membership program. So if you want to become a member, go on the YouTube channel, become a member, $10 a month, teach you how to weld. And this is kind of stuff that we do. So, any stick welder can do this. Any simple stick welder can do this. Can you stick weld magnesium? It's a great question. I don't know. My guess would be no. First off, TIG welding magnesium is incredibly difficult because magnesium is, well, flammable under the right conditions. And of course, welding it is incredibly difficult with TIG. That is a question that I had on the back of my head, so I might look into it. Because if it is, I'm gonna try it. So stay tuned to the channel, and I'll find out. If it is possible, I'll do something on it, but I don't think it is. Anyways, let's get this thing fired up. I gotta reorganize my cords again. This is a mess. What do I do here? There we go. Okay, so this is stainless steel, and where'd my other piece go? Okay. So, now, of course, with stainless steel, just like anything else, and just like welding, TIG welding stainless steel, you want to keep your total heat input as low as you can, because otherwise you can burn it out. Now, I don't have any gas. I don't need any gas to weld with stainless when it comes to stick welding, of course. Let's turn this thing down. So, I'm going to have these coupons. They're the same size coupons as as a mild steel. This is 332 308L stick welding electrode, specifically for stainless steel. So it's going to stay stainless steel. Now, the one thing about stainless is that when you're stick welding it, this slag that forms, it forms while the metal's hot. Stainless steel expands and contracts about 50% more than regular carbon steel, so when it contracts, it's a lot of pressure on the slag and it flies off. So you got to be careful with it. You'll hear the tinging when I'm done. Whoops. There we go. Let's get it tacked up here. Okay, why is it so hot? Oh, because I did not turn it down. My bad. Shit, I didn't mean to make it that. I had it at a lot of amps. Whoopsies. These are also blue demon rods. Heat, say 55 to 75. You know what I'm going to do? In order to keep the heat input down, I'm going to do something else. These are also blue demon rods. I'm going to show you something. These are 16th inch. Yeah, they're tiny. 16th inch 308L rod. Now I have like 25 to 45, I think is what the doc says, as far as amperage goes. 25 to 35. Alright, we're going to put it up in the upper range. 25. You go 35 amps. That way we keep some color into this material. And it's a little wiggly, so it's kind of a little difficult to do, but we'll do it anyways. Hey. Now slag is very thick. These rods heat up very quick. Whoops. And hard to run. Now, I have to be careful because this slag is going to want to pop off and you're crazy at me. I need to turn that hot start down. There we go. Alright. Let's get the slag off. There's even, before I wire brush all this off, you can even get some decent color out of it too. Bless me. Excuse me. Yes, there's a little hole through there. Little hole through there. Let me try the other side while it's still hot. Do the other side. Hope I don't cook it. We'll try it anyways. No, so for stick welding aluminum, you have to have a very specific electrode. I'm going to get to it here once I get this done. Whoopsies. Right, that was a much smaller weld bead and also went a lot quicker. That's the basics. Now, the nice thing about this stuff is that people that are trying to do exhaustless with one out of stainless steel, yes, stick welding is hard when it comes to this. It's very difficult. TIG welding first too. That's better. See, you even get some color out of it. Okay? Now, here's a piece. Now here's a piece of stainless steel exhaust tubing. It's just a piece of practice tubing I was using. Okay, I can stick weld this. It's not as pretty as TIG. Let's be honest. It's just not. But I can still do it. And if I can do it, you can certainly do it too. I'm not saying I'm anything special when it comes to this stuff. It's just, I've had time to be able to practice and I'm not going to call it perfected because I'm not perfect. But I've gotten pretty good at it. Same rod, turn it way down. I'm actually at like 20 amps. So yeah, any 110 Allen can do this. And I'll just weld the seam. Now I gotta move pretty quick. Okay? Turn it up a little bit. I might try another spot to see how well it goes. It's been a little bit since I've done this. It still don't look too bad though. I'm a little wiggly. There you go. Okay? You can weld stainless steel exhaust tubing with a stick welding electrode, and it still looks halfway decent. Let me turn it up and I'll run turn on 25 amps and I'll run a little bit more. A lot of arc flow today though. There we go. Oh man. There you go. Okay. Still run pretty well. That's stainless. Yes, you can stick with stainless. All sorts of thicknesses, all sorts of materials, all sorts of stuff. All right. 16th inch Blue Demon 308L-16. Also at 332. All right. Now we're gonna get to the interesting stuff. Aluminum. And I'll be able to answer some questions that have come across. Now, to answer this question simply, yes, you need a very specialized electrode in order to run it. E4043. This is also a Blue Demon rod. This is 332 E4043 electrode. It has a special coating. It's made of aluminum. If you try to use 6011 or any other steel electrode on aluminum, it's not going to work. I promise. Although, funny story, if you look up on Google if 6011 can run aluminum, it'll say yes. That's not true. Okay, now these are also Blue Demon E4043. The one thing they need to realize when you're running aluminum on these. A couple things. Number one, this is not the most fun process to do. I would only do this. E4043 is for aluminum. E308L is for stainless. The only reason why I would do this is because I don't have anything else. This is not a fun process. This is very difficult to do. So, amperage range for here is 50 to 80 amps. Now, aluminum is a funny, very interesting type of equipment because aluminum is very interesting material because it takes a lot of heat to run it. So 50 to 80, I'm going to turn it up to 60. And we're going to pray to God that I can do this. Now with proper practice, you can get it to do really well. Now, a question that came up was, do you run DCEP or DCEN? DCEP is direct current electrode positive, which is reversible polarity, which is the electrode holder is plugged in the positive side. DCEN, the electrode is plugged into the negative side. That is actually a really good question. That's a really good question. I'll tell you what. The one time I did it direct current electrode positive, the normal way. So positive lead is the electrode holder. That's the way I understand to do it correctly. However, I'm in a trying mood, and I think we'll try DCEN as well. So I'm going to cut these in half, and we'll try DCEP and DCEN because the question came up and I want to answer it. Now these things are very hard to get, these rods are very hard to get started, and they get consumed very quickly, and the slag is very thick and very hard to see through. And of course, the material doesn't change color like steel. Steel gets red and yellow and all this stuff, you can see what's going on. Aluminum doesn't, it just gets shiny. And when you're stick welding aluminum, it's really hard to see the part. So I'm gonna do my best. I haven't done this in a while. I've only done it, you know, a small handful of times. I'm gonna do one DC EP. This one's gonna be direct current electropositive. So my electrode holder is plugged into the positive side. We're gonna run at 60 amps, and we're gonna see how it goes. Come on. Come on. So the only thing is that with this, it almost feels like I have to like force it in. There's no waiting for it to fire up or anything like that. I might even turn my hot start up to help me. Turn my hot start up to help me a little bit. Come on. It's incredibly difficult to do this. It is. Mohawk Chris, I'm trying to show you how to stick weld aluminum. I'm gonna warn you right now, this is a hard thing to do. Alright, I definitely need to turn that hot start off. But I got it tacked. That's all I'm cared about right now. So I'm going to run this side. I got it tacked. Let's rub some of this. Alright, got it tacked. Now, this is going to get consumed very quickly. I don't know how it's going to work, but we're going to try it. Turn it up a little bit. That's how fast it goes. Yes, I'm trying to weld aluminum. It's not, stick welding aluminum is, for lack of a better word, it's a pain. You can do it. And to be honest, the more material you have, the better. But it's tough. But actually, to be honest with you, this didn't come out that bad at all. I mean, all things considered, I'm alright with that. Alright. Well, Mohawk Chris, if you want to join my live sessions, I'll teach you how to weld live in your garage, Friday nights, every other Friday night, 9 p.m. Eastern Standard Time, unless we come up with some conclusion that that's not a good time. And I'll try to make accommodations as I can. I intend to start teaching people how to stick weld because it's the most versatile and easiest to get started in because of the price and because the equipment's simple. But we'll see where it goes. It's a consumer-based program. We can teach you how to weld. You don't have to go to a welding school to do this. But it is also not to take place of welding school. That is an important factor. All right. So, $10 a month, 2 Fridays a month, live sessions with me, and I kind of want to do it in this kind of like Zoom call type thing where we have everybody on live. I don't know if that's going to happen right away, but I want to work to that. Anyways, back to this. One of the guys on YouTube asked if it's DCEP or DCEN, which it doesn't say on the package. I believe it's supposed to be reverse polarity, which means positive, the ground is negative, but I'm gonna try it. Mohawk Chris, you can get a stick welder for like $100. Honestly, one of the machines that I have that I keep on my truck is $125. It'll do 160 amps. They work great. Stick welding machines are, in my opinion, they're all relatively very much the same. So, somebody trying to sell you a $1,000 welder that only does stick, they're out of their mind. Anyways, now we're going to try DCEN. I have never tried this. So I'm going to plug my ground in my positive side, my electrode holder in my negative side. We're going to try. .332 E4043 from Blue Demon. We're still going to run about 70 amps or so. I'm going to leave it at that. And I'm going to get this tacked up, hopefully, and see how it works. Load up, damn it. See what we do. I don't know how well it's going to work. I have a feeling that DCEN is not going to work so well, but I'm going to give it a fair shot. I'll show you how to do Mohawk Chris. You can get something like a Yes Welder stick welder that plugs into a 110 wall outlet for $100. Blue Demon sells a welder that does TIG and stick for $400. Pretty much any welder that can do TIG can also do stick, but yeah, I mean, you can go to Harbor Freight, get one of the Chicago Electric ones. That's what I started on. I'm telling you, the only thing about the Chicago Electric duty cycle sucks. I would go to the Titanium or the Vulcans and get a stick welder there. You're not wrong about that. But to be honest, as a stick welder myself, I never had a digital display. I was also on engine-driven machines. Come on now. Honest to God, this slag smells like soft pretzels. I'm not gonna lie. Troy, what's going on is I'm showing people that they can stick weld aluminum. Now, early in the video, I started off with making a flux core weld that is just as strong. Actually, it turned out to be stronger than a TIG weld. And I also did some stainless steel stick welding. The idea is I'm trying to promote my YouTube live program that I'm doing, where for $10 a month, I can teach you how to weld in your own garage. All you need to do is to go on the membership tab, select the highest tier of live sessions. I will do live sessions. Well, I tell you what, next thing I'll do, I'll show you that my yes welder here can even run 6010 on 110, on a 120 outlet. 6010 is notoriously hard for welding machines to run, and I'll show you that it can do it. First, I'm going to see if this will do DC negative. I'm having a feeling probably not, but I'm going to try it anyway. That's what we're here to do. Turn it up a little bit. Here we go. Alright, so I'm going to go with probably not. You got to run DCEP. I can't turn it up. I'm running pretty hot. Running about 85 amps, so that's hotter than these lots of paint. So DCEN, no. DCEP, yes, although not the easiest thing in the world, but it'll do it. Now, the next thing that I want to debunk. $6010. Well, somebody said 6011 on a yes welder is they don't run very well. Well, I'm here to tell you that if a machine can run 6010, the machine can definitely run 6011. Not necessarily the opposite. I'll show you. Do I have a piece of mild steel sitting around that I can weld? Not sure. I'll come up with something. I can use these. Use these spring purchase. They've been around for long enough. They ain't doing nothing. This is 6010. This is 1/8 inch 6010. Okay, and these are not new rods. They're kind of old. So I'm gonna run it. Now again, I'm still on 120. I'm gonna run at 80. I don't know if it's gonna do 85 amps. I'm on a 120 socket. I'm on a 120 socket. It'll run about 82 amps, which is like the bare minimum for this rod, really. You know. I want to bead right here. Get it tacked up. Whoops. Okay. Tacked up, like I said, 1/8 inch 6010. 6010 is notoriously difficult to run on inverter driven machines, especially the cheaper ones, we'll call them. So I'll show you. Come on now. That's a little better. I could probably turn it up a little bit, but I'd be afraid to blow my circuit, to be honest with you. It'll do it. It'll run 6011 better. I wish I had some 6011 to show you. I just don't right now. But it'll run. It'll do it. You want me to explain the numbers? That's a great question. All right, 6010. The 6 and the 0 are the tensile strength. So it's 60,000 psi of tensile strength. Okay? The 1 is the position. So for 1, we can do all positions. If it's a 2, it's flat and horizontal only. And then the 0 in 6010 is the chemical composition of the flux. So a 0, a 1, and a 2, that's kind of a cellulose base, which is like plant-based. And then something like a 6 and an 8. I think it's a 6 and 8. Yeah, 6 and 8, they're low hydrogen, and then there's stuff in between. I don't remember all of them on top of my head, but that's kind of the idea. Yeah, that was on a 110 outlet. So, what was the other comment that I had? Well, here's the thing, Jimmer. What you're saying might be accurate, But the thing about welding is that you have to be a reaction-based welder. If you're just basing your welding off of numbers where you have to stay at a 45-degree angle or you have to keep your angle at 90 degrees, you're not doing so well because you have to react to the puddle. If the weld wants something else, you give it something else. You don't just stick to your numbers and say, nope, too bad, I gotta stick at a 45-degree angle because that's what the book says. Not gonna get very far. That's that. So yes, these Yes Welder machines, they can run 6010 and 6011. I would highly recommend just running 6011. The only reason why I have 6010 is because I was a pipe welder for a long time and I have like 100 pounds of 6010. It's the only reason why I have it. So get 6011 if you're looking to get it. The other thing, I'll show you guys some 6013. Now, this will be the last one that I do for tonight. Jimmer, I don't know what you're saying, but if you're not here to be any part of it, then I'll just kick you out. I don't have time for bullshit. What else do I got here? Well, I've been welding for 13 years there, Jimmer, and I really just don't have time for your antics. 7018 is not for aluminum. Holy crap. All right, let's get him out of there. Anyways, yeah, 6010 is for typically roots. So 78, yes, to answer your question, yes, 7018, I have some of that too. 7018 is for pipe. 6010 is for root passes on pipe. It is also for fill passes and caps if you're into API 1104 or natural gas and oil pipelines, which is downhill runs. So you do a 6010 root and 7010 or 8010 hot pass fill and cap. Okay? If you're doing an uphill weld, you got a 6010 downhill route typically, and then 7018 up the rest of the way. Now, there is talk about API going to a 7018 hot fill and cap, but that's a conversation for another day. As of right now, they're still doing downhill. So it's 6010, 8010, and then for ASME and pretty much every other part of the industry, it's 6010, 7018. I'll get out of that. We're more talking about stuff that you guys do in your own garage. 7018 is a good rod to have. I don't always recommend it because ideally you should have 7018 in a rod oven. And rod ovens are expensive and most people don't have them. So I do have some. No, it's not in a rod oven. And if I was ever to do something for a client, I would never use it because I wouldn't trust it. The other thing I can show you before I go is 6013. 6011, now to keep in mind, 6011 and 6010, those are interchangeable. So in a weld procedure in the field, if somebody has a 6010 root and all they have on their truck is 6011, for the most part, we'll let it go. It's not that big a deal. They're interchangeable rods. You're not really supposed to do that, but yes, you can. And we're talking about home projects. We're not talking about weld procedure work, so yes, you could get away with that. Weld procedure work, there's no way in hell you'd be able to get away with that. But that's not what we're talking about. So yes, you could get away with that and be okay. Now, .6013 is a, we'll call it a finicky rod. I don't like it. I'm going to level with you right now. I don't really care for it. Now, it does come in smaller sizes, and it can be used to fill up spaces, and it can look pretty decent. However, the material has to be a little bit cleaner. Your technique has to be on point, and yeah. It's a very good rod to have, though. It's a very good rod to learn to run. Because just like stick welding and anything else, you use 6013 to weld on dirtier metal. This has been powder coated. All I did was brush the powder coating off. I can get away with 6013. Is it my favorite? No, this is not my favorite rod. But yes, I have used 7014 in the field, but I've only ever used it for root passes. I've never used it for anything else. Moving on. So this, what I have here is Lincoln Electric's 5/64 6013. Okay, this is all 5/64 6013. They say for you 65 amps. I'm going to run every bit of 65 amps. And it's a fill freeze rod, so there's no whipping like you did with 6010 or like 6011. This is just a fill freeze rod. You just drop and drag it in. I like to use a little bit of an incline or cheat a little bit to keep that slag away, but the biggest problem that I have with 6013 is that you tend to always run over the slag and get these little pockets. I get really annoyed by it. But you prepare right, get your fitment right. This stuff does work pretty well. I've used a lot of it on my little lawnmower project I got going. But I'll do a little beat to show you. I guess powder coating fine. That's it. Okay. Yes. Shaft cruisers. Yes, I do like Yes Welders. I was doing some contract work for them for a little bit. They allowed me to test some of their equipment. I did have a little bit of a hand, along with a bunch of other people, not just me, in kind of preparing them for this next generation that they worked on. And shaft cruisers, to be honest with you, I much prefer 6010 over 6011. I just think 6011 is a better rod for the home consumer because 6010 is notoriously difficult to run, especially with inverter-driven machines. So 6011 is typically a better rod for the garage work, but as far as field work and everything, I will always prefer 6010, and more than likely you guys will see me use 6010 in my garage way more than you see me use 6011. I just refer to 6011 because it's an easier rod to get a hold of, easier to use, and a little less expensive. 6010 is kind of a specialty rod. And I'm going to pronounce your name Yoska. Your question is, for a cheaper welder, yes, the slower that you go, the more penetration you get. You just got to be careful as to how slow you go because you can run too much. Now, the other question you have is, would you prefer 6010? The reason why I prefer 6010 is because I'm a pipe welder. That is all I have ran for 15 years is 6010, 8010, and 7018. I have dabbled more into it because I've done other home projects, but as far as field work, the most experience I have is with 6010 and 6010 and 7018. It's just the most, I'm more comfortable with that rod than anything else, just because of how much time I have with it. It's not necessarily stronger. Matter of fact, 6010 is actually not as resistant to metal fatigue as what stuff like 6013 and 7018 are. Matter of fact, 7018 was designed to be resistant to metal fatigue. 6010 is not. It can be pretty brittle. But no, I have not, shaft cruisers, I have not had much issues running 6010 on the S-Welder. As a matter of fact, that's a recommendation I made to them some 2 or 3 years ago, was that I want to be able to run 6010. And they were able to do it. Good question. Why is 7018 preferred over 7014 if they hold the same tensile strength? because 7014 is not a low hydrogen rod, and low hydrogen rods are notoriously can withstand up to a lot more metal fatigue resistance than what 7014 can. So if I take a piece of metal and I twist it back and forth, a weld with 7014 will break before 7018 will. Hydrogen is the enemy to welds. And a low hydrogen rod like 7018 is much better than 7014 because of its metal fatigue and hot crack resistance. That's why it's used in the field for process piping a lot. Alright. So as you can see, once you get this rod going and you get it all heated up, it runs pretty well. It's a good rod. Alright. What time is it? Alright, so I will stay on for another 5 or 6 minutes. Yeah, I'll stay on for about 5 more minutes or so, and then I'm going to get off. But that is kind of an example of what you can expect from my online live classes. So for $10 a month, you can weld live with me twice a month, Friday nights, 9 p.m. Eastern Standard Time. First night's going to be January 10th at 9 p.m. And I'm going to teach you guys how to weld. And it's not necessarily like, it doesn't have to be start from the basics and bore you guys to death. But if it is something where you guys are just getting into the industry or getting into the hobby and want to learn how to do it from the basics, we'll start from the basics. If I have a bunch of people that don't need to start from the basics and want to learn some more complicated stuff, how to fit, how to weld, how to set up their machine, stuff like that, we'll go right into it. But this is a members only thing, because it takes a lot of time and a lot of effort. I got Blue Demon Welding Products sponsoring this thing, so I'm really hoping to get it to move on. So guys like Yoska, Chap Cruisers, if you guys want to learn more, you guys might be, Yoska, you said you're brand new to this stuff, great. Sign up for the membership program. I can give you all the information you need. It's going to be kind of a community-based program. We're going to have a lot of fun with it. Chap Cruisers, it sounds like you have some experience already, which is really great. If you want to learn more, if you want to talk more welding, if you want to add your own input, I'm okay with that as well. $10 a month. You can get on, learn to weld with me. I'll show you how to fit and fab, how to set up your machine, all that stuff. I have become more of a Yes Welder expert, I guess, because of my experience with their machines. Well, Chap Cruisers, I appreciate you. I appreciate the input that you've had. It's been very informative. I have not had to. Yeah, you just had really informative comments, so thank you. For the course, it's $10 a month. $9.99 a month. Through the YouTube memberships programs, you go on my channel, you can join the membership. If you don't need the membership and you just want to be part of the live stuff, you can choose the interactive. You'll be part of the live community. You'll be part of all the chats and everything. But if you want to learn how to weld, or if you want to be part of the welding program, $10 a month. My initial thought was I was going to start with stick welding. Now I'm going to show you guys what you need. I'm going to show you guys I was going to explain the rods and what they all, differences between some of the more common rods, where to get the rods, all that stuff, how to set up a machine, the differences in the machine, the differences in the settings, what it looks like, getting good beads set up, getting good angles, getting good rods, good weld clean, all this sorts of information. I'm a certified welding inspector, certified welding educator. I've been a certified welder for 15 years in the pipeline. I've also done a lot of other things. One of my bigger projects that I've done lately is this wild twisted exhaust system. I can teach you guys how to do pie cuts and how to do stuff like this. Chap Cruisers, you got a TIG 205P. I can teach you how to do this stuff as far as pie cutting and everything. It's not easy, but I can show you how to do it. And it's community based. It's what you guys want to see. I'm not going to sit here and go through a curriculum. I don't have everything set out in stone. I have a direction I want to go. I have to let, you know, Blue Demon and some other people know exactly where I'm going, but why isn't MIG or flux core used in pipelines instead of stick if you say they are the same strength? Simple. The simplest answer is because they are simple. For example, I can put a engine-driven welding machine and a bunch of stick rods on my truck and go. I don't need to worry about wire feeding. I don't need to worry about the gun. There's just less variables to worry about, because when you're on the pipeline, you're in the middle of nowhere. If my wire feeder goes down and I have a bad roller, I've run out of tips, you're stuck in the water. Stick welding, it's a much simpler process. Also, to be honest with you, flux core was designed in the 50s to take place as stick welding. The problem that they had was portability, convenience, and ease of maintenance. That's why stick welding is still a thing. And it will always be a thing. It's not going to go anywhere. As much as people say it will, it's just not. Now, MIG's not a thing because out in the field, when you're out in the elements, MIG's not really good with dirt. And I'm going to tell you right now, as a pipe welder, there is no such thing as a clean weld. Everything is always dirty. So, and that's where stick welding gets both. Not only that, but typically speaking, with the amount of heat input, stick welding also gets better penetration per amp than any other process. If that makes any sense. Should. Takes more time. Less efficient. It's the oldest process. Oldest arc welding process. But yeah, that's basically why. 6010. Favorite electrode? 6010, without a doubt. I can do anything with 6010. Best combination though is 6010, 7018. 6010 or 6011, you get the deep penetration power of 6010, but then you cover it with 7018 and you get the metal fatigue resistance. Most of the projects that I do at home, that's what I do. 6010, 7018. I'll stay on for 3 more minutes if anybody has any other questions. No. I have never tried to stick weld 2 razor blades together, and to be honest with you, I don't think I ever will. I can TIG weld them together, but stick welding them, the penetration power is just way too much. If somebody challenges me to it, I might try it, but I can't promise anything. Yeah, it would be a great challenge. I definitely can't promise everything with that one, though. But that's kind of what we're looking at here. This is kind of what I've got going on. The other project that I am working on is this little lawnmower project. It's been a longer project than I planned on. I just have more going on than what I intended to. So I have an exhaust project. I've got this revolver that I'm building out of sockets. It's just a display piece. And I've got another exhaust system for an Indian that I have to do. The next question that came up, best budget stick welder. This may not be the answer you're looking for, but this is the answer that I have, and it's anything you can get your hands on. Like I said in the beginning, $100 stick welder can do more than you think it would, honestly. If you get one that plugs into a 110 outlet and can have at least a 60% duty cycle, you're in the game. And most machines anymore can. I'm going to say the simplest machine that I can get a hold of best budget stick welder. I would say overall, the best budget stick welder would be a Miller Thunderbolt. You can get them, Hobart makes them now. Miller Thunderbolt was an old stick welder, transformer driven stick welder. That was a great machine. They can run 6010 really well. They do take 240. They do not take 120. But Hobart now makes it. Now, Hobart and Miller are kind of the same thing. Hobart gets kind of Miller's last generation technology. So, and it's still holding with a boat on it. Those little things are right. I mean, that's what I mean. These stick welders that are $60, $80 on Amazon, whatever, they work. It's a very simple concept for a welding machine. It's a step down transformer. That's all it needs to be. It's a very simple piece of equipment. So, you know, $60, $80, $100 welders that you can pick up, they work. I don't know what their duty cycles are, so I don't know how long you can use them at their highest amperage, but they do work. I wish I had it with me, but here, I'll show you my machines. This will be the last thing I do, and then I gotta get going. I'll show you guys my machines real quick, because that's the question that I get all the time. I have another machine, I just don't have it with me. Somebody else is borrowing it. But this is a Yes Welder YWM 211P. This is a multi-process welder. This does pulse MIG. It also does lift arc TIG. I don't use it for that. And it does stick welding. This is my primary stick welding machine, actually. Now the one below it here, this is my Miller, or my Yes Welder TIG 200P. I use that for all my TIG welding right now. I am trying to get my hands on a Blue Demon Genesis to use. They are really sweet machines. And then I also have a Yes Welder YWA 160 that I use, and I kind of keep that in my truck most of the time because, you know, you never know what you run into. That YWA 160 works fantastic. All right, well, I've got to get going. I got to go to bed now. But thank you, everybody, for listening in. Again, if you guys want to get into the action and become part of this welding community, go to my YouTube page, become a member for the live sessions tab for $10 a month. You can learn to weld with me, teach, learn from my teachings. You can also put your own input in. It'll be a live community, and I kind of want to get this together to where I can actually do like kind of similar to like a Zoom call. We're all getting on live and kind of doing welds together. You can show welds, I can give you feedback, work on projects together, stuff like that. I think it's going to be a really interesting and cool thing to go, and I'm just going to kind of let this organically grow. So I don't have a set plan. I have a direction I want to go, but if somebody wants to see something, I'm more than willing to do it. Takes place first night, January 10th, 9 p.m. I'll get on. Ideally, I would like to start from the beginning on how to set up your machines and stuff. But if you guys want to see something else, we'll go with it. And typically the sessions are going to be roughly 2 hours or so. Basically as long as this session was. So this is a really good explanation. Now this one went a little bit further than what I would do with the others as far as kind of picking little pieces here and there. I'm going to focus a lot more on, okay, today we're going to work on 6011 and show you what it can do. That's kind of the idea. But I'm going to let it grow organically. And then we'll get to the point where I start doing projects based on what you guys want to see and maybe even do them together so I can help you with them because I have a book of projects. So thank you everybody for watching. Stay tuned for more stuff like this. I'm really excited to get this kicked off and get started. I had intended on getting more stuff done tonight, but this was fun nonetheless. And hopefully, I'll see you guys January 10th. Or on any of the other lives. I'm still going to do a live pretty much every night / morning. So that's just what I do. But thanks for watching. Go to the YouTube channel, become a member, $10 a month. Learn how to weld with me. I'll see you later. Where are we at? There we go.